Hello, this is Jennifer Martinez, and in this video we're going to talk about row echelon forms. Reducing a matrix to row echelon form will allow us to analyze any system of equations of any size. A rectangular matrix is an echelon form, or sometimes called row echelon form, if it has the following three properties. The first one says that all non-zero rows are above any rows of all zeros. So an example of this is, or rather, I should say that an example of a matrix that is not an echelon form versus one that is. The matrix on the left here, this 3 by 3, is not in echelon form because it has a row of zeros right in the middle there. And number 1 again says that all the zeros should be at the bottom. So that's an easy remedy. We'll just interchange row 2 and row 3 and this to become this matrix on the right. And you'll see the rows, the zeros are now at the bottom. So now let's go back and look at number 2. Number 2 states, the second property is that each leading entry of a row is in a column to the right of the leading entry of the row above it. So all the leading entries must be in some sort of diagonal situation. Let's look at an example of that. Here's an example of a 3 by 3 that's not in echelon form, and it's because the leading entry to the first row or to the second row is not to the right of the first row. Again, that's going to be the same remedy. I could just switch those rows, row 1 and row 2, and then it would work. It does not have to be in a diagonal anymore. So believe it or not, this is still in echelon form because this second row now, this leading entry in the second row is to the right of the leading entry to the first row. And you can see the row of zeros. If there is any rows of zeros, it is at the bottom still. So it still satisfies number 1. So now let's move on to number 3. All entries in a column below a leading row entries are 0, which by the way, in our 2 forms here, notice how there's 0. All the leading row here is the first and the second leading. These are the 2 leadings, and there's zeros behind both of those. And even in the second one, even though it's missing that one, here this is called the leading, and there's zeros below it, and the last column is the next leading, and there's a 0 below. So here's an example that is not in echelon form because it does not have a 0 below that leading entry. That is an example of number 3. It also doesn't satisfy number 2 either because that leading in the third row is not to the right of the leading in the second row. But we can fix that by multiplying -1 times the first row and add it to the third row. Actually, I mean -1 times the second row and add it to the third row. And to do that, we're going to leave the first row alone. We have the second row, we'll leave that alone. And the third row, if we put a -1 here, this becomes 0. This becomes 0. Oh, you get that. And this becomes 0. So -1 times 0 plus 0 is 0. -1 times 1 is -1. Added to 1 is 0. And then -1 times 0 added to 0 is 0. We get that first matrix there. And remember, the 3 things that we can do to get things in echelon form from the last section to row reduce is we can, this is the last one we just did, replace one row by the sum of itself and a multiple of another row. We can also interchange 2 rows. And we haven't done this last one yet, but we can multiply all entries in a row by a non-zero constant. So that is echelon form. Now, if a matrix in echelon form satisfies the following additional conditions, then it's called reduced echelon form, or sometimes known as reduced row echelon form. So the leading entry in each of the non-zero row is 1. So we must have, number 4, the leading entry of each non-zero row to be 1. And so here you can see in this last example, it does satisfy echelon form because we have the first leading entry is to the right of the one before. We have no row of zeros, and there is zeros below each entry, leading entry. But it is not in reduced because of this 2 here. So let's try to fix that. So if I just take that second row and multiply it by 1/2, then put it back into that second row, you can see now there's a 1 in each leading entry. And we can do that because if we look down below, number 3 says you can multiply all entries by a row by a non-zero constant. We saw those properties again in the last section. But this is still not in reduced echelon form because there's a last property. To get something in reduced echelon form, property number 5 states that each leading one is the only non-zero entry in its column. So that means you need zeros above and below. If you look at our first 3 examples, these were in reduced echelon form because there were zeros above and below each entry, and leading entry, and each leading entry was 1. But here in ours, they're not. So let's fix that. I'm going to take -1 times row 2 and add it to row 1 and put it into row 1. Again, the only thing that's changing is row 1. And I'm using the entry, that leading entry, always as the pivot. So we're going to have -1. So the first entry would not change in this first row, but we have -1 times the 1, which is -1, added to the 1, which is 0. Oh no, I made a mistake here. This should be a 1, otherwise that needs to go to the bottom. Okay, let's make sure. A -1 times 0 added to 1 is 1. -1 times 1 added to 1 is 0. And then the last one, 0 plus 0 is still 0. Now it's in reduced echelon form. The first 3 were reduced as well. So this one was reduced. First one was reduced. The second one. The third one. But these 2, the 4th and the 5th, are not reduced. We saw why above, and then finally reduced. Here's 2 triangular matrices from the last section that are in echelon form. This first one here is in echelon form. Let's consider this a 3x4 augmented matrix. I put the line right there to show that. Even though this does not have a solution, there's no solution, it is inconsistent because of this last row does not make sense if you put that back into a system of equations. But it's still in echelon form because it satisfies the 3 properties. There's no row of zeros. The second property here, each leading entry of a row is in a column to the right of the leading entry to the one above it. And then there are zeros below each of the leading entries. It's not reduced because there's a 2 there, and there needs to be a 0 above and below to the leading entry on that second column. But if we look here to the right, this one is an example of a matrix that is considered a reduced echelon form because it not only has the 1s here, but it has the zeros above and below. For different size matrices, example 1 is good. Let's look at example 1. Example 1 has some weird size matrices where maybe you have more variables or more equations, they have variables, or more variables than you have equations. Both of these are in echelon form. By the way, the little rectangle here represents, it says any number may have non-zero values, any non-zero value, and the stars can be any value, including 0. So you can see these are non-zero, these little rectangles, and it is in echelon form because the zeros are at the end. Number 2, each entry is to the right of the one above it. Same with here, even though we have a column of zeros here. And all the entries below that leading are 0. It's not reduced because those don't necessarily have 1, so they changed it to a reduced here, the same 2 matrices. They put 1s here to make it reduced, and they added zeros above it. Notice how you can have columns with any numbers here, as long as these are 0 right there. So here's where the pivot positions are. The definition of a pivot position. We talked about these before. The pivot position of a matrix is a location in a matrix that corresponds to a leading 1 in the reduced echelon form of a matrix. So all these are pivot positions. And then the pivot columns is the columns that contain that pivot position. So here are all the pivot columns from example 1. So let's look how to row reduce matrix A into echelon form. And here are the steps I'm going to use. So I'm going to start with that. There's no way that 0 there is going to mess us up. There's no way we're going to get a 1 to the right of that because there's no column of zeros here. If this was a column of zeros, I wouldn't worry about it. But since there's numbers here, I'm just going to interchange maybe 1 and 2, or better yet, 1 and 4, since there's already a 1 there. So now I'm going to, second step, this is my pivot. I'm going to get zeros all down below. I do not know if this is an augmented matrix, so I'm just going to not put the line there. The first row does not change, and this becomes 0. The next one is 2, just adding these, 4, -6, and -6. Now I'm going to, at the same time, might as well get the 0 in the third by taking 2 times that same pivot, row 1, adding to row 3 and putting row 3. So I would get 0. The next one I would get 8 plus -3 is 5. The next one, 10 plus 0 is 10. -18 plus 3, -15. And finally, -14 minus 1 is also -15. The fourth row already has a 0, so I'll leave that the same. I'm just going for echelon form, but I'm still going to get a 1 right there because I do not feel like dealing with that 5. I could take -5 halves times the second row and add it to the third row, but since 2 is common in that second row, I might as well change that to a 1. So I didn't change any of the rows except for that second row. I divided everything by 2. So now I'm going to do step 4. Step 4 here says to cover the row containing the pivot position and cover all the rows. So meaning here's the pivot position of the one before it. So cover this row, column, and this row, and you end up with a submatrix. So then you just pretend you have just that matrix and you do it again. So we already have the 1, we need zeros down below. So I'm going to get them both at the same time. I'm going to take -5 times row 2, added to row 3 to get a 0 in that first entry right there, and then get the 0 in the second entry. I'm going to take 3 times row 2, added to row 4. And what I get, again, the first 2 doesn't change, and I end up with a row of zeros. So now I'm going to interchange, because it's a row of zeros, row 3 with row 4 to get the zeros at the bottom. And that's it. This is in echelon form. Here's the general form right here. Here's my pivots. And here's my pivot columns. Step 5 is for a reduced echelon form, and we'll look at that next time.